All right, welcome to today's tutorial. We'll be solving limit of a function using factorization method. Now, there are some basic questions that you see under limit of a function you will not be able to solve, or probably when you solve with a substitution method, you will not get the actual answer or the correct answer. And if you are yet to watch our videos on substitution method, please do well to look at our previous video. You'll see where we treated limit of a function by factorization method. So there are some questions you cannot solve with factorization with a substitution method. Hence, there is need for us to use factorization method to express such a question. Please do it to subscribe to our channel. Also give the video a thumbs up and share to your friends and loved ones that may be in need of such mathematical challenges. All right. So having a question like this, let's say example 1, limit of x squared minus 16 all over x minus 4 as s tends to 4. Now you may want to try out a substitution method. Yes, you may want to try. Let's see. By substituting, if x is 4, so let's say this becomes what? 4 square, x square, and x is 4, minus 16 all over x in place of s 4 minus 4. 4 square will give us 16 minus 16. 4 minus 4, and that's what? 0 over 0. And this is an indeterminate function, or we call it what? Undefined. So when solving limit of a function, your denominator cannot be 0, or you can't have 0 over 0 as a feasible answer. That is totally wrong. So whenever an examiner gives a question and your answer becomes 0 over 0, it means that there's an alternative method to get the feasible answer for that particular problem. So that's to say, when you solve any question in limit and you use substitution method, because that happens to be the simplest method, and your answer gives you 0 over 0, note that that is not the right method to use. Hence, you have to look at the question and try to express or expand the question to its simplest form so you can get a feasible answer. So if that is the case, to solve this question correctly, now look at the question. X squared minus 16 all over x minus 4 as s tends to 4. If I break, since 16 is a perfect square, I can break 16 such that it becomes x squared minus 4 squared. You agree with me that 4 squared is the same thing as 16 all over what? X minus 4. Then I will take this thing to this side. You know, this is difference of 2 squared. And remember in mathematics, we say difference of 2 squared when we have a squared minus b squared. It is the same thing as the first term a plus the second term b times the first term a minus the second term b. So difference of 2 square is expressed as this in mathematics. Take note of that. Difference of 2 square, a square minus b square, is a plus b. And so one will become positive with both the first and second term, and the other becomes negative. So if that is true, we can now expand x squared minus 4 squared to become what? X plus 4 and x minus 4. You see? All over the denominator, x minus 4. So at this point, we can cancel out this. We're left with what? X plus 4. And remember, as s tends to what? 4. So substitute the value of x now. So that becomes what? 4. Because if x is 4, so substitute 4 for x plus 4, and my final answer is what? 8. So we can also solve another question. Let's see example 2. Take the limit as s tends to 3. Okay, x squared minus 9 all over x minus 3 as s tends to 3. So looking at this question as well, we can solve with a substitution method, because 3 squared is 9, 9 minus 9 is 0. And s is 3, 3 minus 3, 0. So that's wrong. So what you do, use the same factorization method. You expand or you express 9 such that its base is 3, because 9 is a perfect square. It becomes x squared minus what? 3 squared. You agree with that 3 squared is the same thing as 9 all over x minus 3. The difference of 2 squared, one becomes positive with this first and second term times one becomes negative with the first and the second term. So difference of 2 square is expressed in this pattern. So if I even expand this back, it will give us this original expression all over the denominator, x minus 3. So this cancel this, I'm left with x plus what? 3. Remember, as s tends to 3, so in place of x, we put what? 3 plus 3, and my final answer is what? 6. All right. Now let's take another question. Example 3. Example 3, we have another kind of approach. So let's say limit of x squared minus 5x plus 4 all over x minus 1 as s tends to 1. Solution. So if you look at this question, you may feel substitution method may go very well, but that's not true. 1 square is 1, 1 minus 5 times 1 is 5. 1 minus 5 is minus 4, minus 4 plus 4 is 0. 1 minus 1 is 0. So if you use substitution method by substituting 1 for everywhere you have x, you have 0 over 0. And you know that is an indeterminable function and our answer cannot be in such form. So hence there is need for us to look at the numerator very well and think of something we can do to express it such that it has the same elements with the denominator. So I can actually expand this because this looks like a quadratic equation. It has power 2. This is a quadratic function. I can break this down such that I will think of two numbers. When you multiply them, it gives you plus 4, and when you add them, it gives you minus 5. And I think the two numbers are minus 1 and minus 4. Two numbers, when you multiply them, it gives you plus 4. When you add them, it gives you minus 5. So when you multiply minus 1 times minus 4, it will give you plus 4. Then minus 1 plus minus 4 will give you what? Minus 5. So the two factors are minus 1 and minus 4. So if that is true, the two factors are minus 1 and minus 4. So to express this, our numerator becomes x squared. In quadratic, you replace the second term with the two factors. Minus 1 is minus x. Minus 4 will be minus 4x plus the constant here, 4. All over x minus 1. Okay, if this is true, I can group this. S is common here. So we factorize, take x outside the bracket. X squared divided by x, I'm left with x. X divided by x, I'm left with 1. 4 is common here. Take 4 outside the bracket. 4x divided by 4, I'm left with x. 4 divided by minus 4, it is minus 1. All over the denominator, x minus 1. So if you look at the bracket, we have same thing in the bracket. So you take 1, x minus 1. Then the second function you take is x minus 4. All divided by the denominator, x minus 1. So you see at this point, we cannot cancel these ones out. And we are left with what? X minus 4. So x minus 4, remember, as s approaches what? 1. So we are left with x minus 4 as s tends to 1. So it becomes 1 minus 4, and our final answer is minus 3 answer. So the other questions you may want to try under factorization method. So I will leave 2 exercises for us to try. Please do where to drop your answers on the comment section. You just number it, number 1, put your answer there. Number 2, you drop your answer. So please, if you are having or you are getting value for our content, do where to encourage us by subscribing to the channel and also like the videos and share. So I want us to try this. Number 1, take the limit of x squared minus 3x plus 2 all over x minus 1 as s tends to 1. Number 2, also try, I know this may be a bit complicated, but we are going to solve this in our next video. So please follow up for the correction. I'm going to do this correction in case you don't get the answer correctly. X cubed all over minus 27 all over x minus 3 as s tends to, let's say, 3. Then we can also add this, number 3. Now this may be a bit simple. Take x power 2 minus 1 all over x as x approaches 1. All right. So see in our next video, we will be treating maybe dividing with the variable, or dividing by the variable with the highest power. Thank you for staying tuned. We'll say God bless you.